Hello, and welcome to Astronomy Daily, your daily guide to what's happening in space. I'm Anna.
And I'm Avery. It is Tuesday, February 24th, 2026, and we have a busy show for you today.
We do. The big headline, the one everyone in the space community is talking about right now, is Artemis, and specifically what is happening to that rocket at this very moment.
Quite literally, as we record this, the SLS rocket is making a very slow journey, about 1 mile per hour, back to its garage.
We have all the details on that. We also have a genuinely exciting story from Mars, a wild mission concept to chase an interstellar comet. China's mystery spaceplane is back in orbit, and we wrap up with some beautiful red giant science that solves a mystery that's been bugging astronomers since the 1970s.
Plus, we run through this week's launch schedule, and it is surprisingly busy despite all the Artemis drama. Let's get into it.
So, Avery, let's start with Artemis, because this is a story that has taken yet another dramatic turn.
Honestly, Anna, this one stings a little, because just last week we were watching a really successful second wet dress rehearsal, and NASA was talking about March 6th as a real launch date. Things were looking good.
And then Saturday happened.
Overnight on February 21st, engineers noticed something concerning, an interruption in the flow of helium to the rocket's upper stage, specifically the Interim Cryogenic Propulsion Stage, or ICPS.
And just to be clear for listeners who might be newer to the show, what does the ICPS actually do?
Great question. The ICPS is the upper stage of the SLS rocket. It sits above the core stage, and it's what fires to push Orion and the crew on their translunar trajectory toward the moon. It uses helium internally to do two critical jobs. It maintains environmental conditions around its engine, and it pressurizes the liquid hydrogen and liquid oxygen propellant tanks. So helium is not optional. Helium is fundamental.
And this helium flow issue appeared after the wet dress rehearsal had completed, not during it, which makes it particularly tricky to pin down.
Exactly. The WDR itself went smoothly. It was during reconfiguration afterward that data showed the interruption. NASA Administrator Jared Isaacman posted about it on Saturday, saying the team was investigating three possible causes: a blocked filter between the vehicle and ground support equipment, a failed quick disconnect umbilical interface, or a failed check valve on the vehicle, similar to what caused delays on Artemis I.
And regardless of which of those three it turns out to be, the answer is the same?
The answer is always the same. They have to go back to the vehicle assembly building. You can't fix any of those things on the launch pad. So NASA confirmed a rollback, and that rollback is happening today, February 24th. The SLS, Orion, and the whole stack are being loaded onto the crawler and making that 4.2-mile journey back to the VAB at roughly 1 mile per hour.
Which takes several hours. It is not a fast vehicle.
It's not. The crawler itself weighs about 6.5 million pounds unloaded, and it's burning around 165 gallons of diesel per mile. It is an extraordinary piece of engineering in its own right.
So where does this leave the mission timeline?
March is definitively off the table. Isaacman was very clear about that. April is now the earliest possible window, and NASA has said that quick action to get back to the VAB could still preserve April. A full media briefing is expected this week. The crew, Commander Reed Wiseman, pilot Victor Glover, mission specialist Christina Koch, and Canadian astronaut Jeremy Hansen, had just entered quarantine and have now been released again. This would be their second exit from quarantine.
Which tells you something about how hard this process has been. And this is still the first crewed mission beyond low Earth orbit since Apollo 17 in 1972. The stakes are enormous.
They really are. NASA's under pressure, both from the public and from the White House, to get this done. Isaacman has been quite transparent about the challenges, which is appreciated. We'll keep you updated as the investigation progresses. A media briefing is expected this week.
Okay, let's lift the mood a little because our next story is genuinely brilliant, and it comes from Mars.
This is one of my favorites of the week. NASA's Perseverance rover has just been given something that effectively functions as GPS on a planet that has no GPS satellites whatsoever.
So, how do you navigate on Mars? Walk us through how it used to work.
So, historically, Perseverance used a system called visual odometry. Every few feet, it takes camera images of the surrounding rocks and geological features, and it tracks how those features shift in frame to estimate how far it's moved. It's clever, but the problem is that tiny errors add up. On a long drive, the rover's internal sense of where it is could be off by more than 35 meters. That's over 100 feet. When it hit that threshold of uncertainty, its safety systems would kick in and it would just stop and wait for instructions from Earth.
And with communication delays of up to 24 hours, that could mean an entire day of lost exploration time.
Exactly. So NASA's Jet Propulsion Lab developed a new system called Mars Global Localization. Here's how it works. Perseverance takes a full 360-degree panorama with its navigation cameras. Then an algorithm compares that ground-level view with high-resolution orbital maps captured by the Mars Reconnaissance Orbiter far above. It matches the terrain, the ridges, rocks, slopes, and triangulates an exact position. The whole process takes about 2 minutes.
2 minutes to know where you are with 25-centimeter accuracy? That is remarkable.
What makes it even cleverer is where the computing power comes from. It runs on the helicopter base station, the processor that Perseverance used to communicate with Ingenuity. Ingenuity flew its 72nd and final flight last year, so that processor was sitting idle. It runs more than 100 times faster than the rover's main computers. The team essentially repurposed it.
So Ingenuity keeps giving even in retirement.
It really does. Mars Global Localization was used successfully for the first time in regular mission operations on February 2nd and again on February 16th. JPL's chief engineer of robotics operations, Vandy Verma, described it as giving the rover GPS, saying it can now drive for potentially unlimited distances without calling home.
And this has implications beyond just Mars, doesn't it?
Big implications. NASA's already looking at adapting this for future lunar missions, where you have difficult lighting conditions and long, cold nights that make precise location data even more critical. And if we ever have astronauts driving pressurized rovers on Mars, they won't be able to wait for Houston to tell them where they are. This is exactly the kind of technology they'll need.
What a story. 5 years on Mars and Perseverance just keeps getting smarter.
And hopefully, so are we.
Now, this next story, I love this one because it is genuinely audacious. We're talking about a mission concept that was published this week for chasing down an interstellar comet. Avery, set the scene.
Right. So our audience will remember Comet 3I/ATLS, the third confirmed interstellar object ever detected in our solar system, discovered in July 2025. It came screaming through from outside the solar system, made its closest approach to the sun last October, swung past Venus in November, and came closest to Earth in December. It is now racing away from us at over 60 kilometers per second.
Which is extraordinarily fast. For context, that's faster than any spacecraft humanity has ever launched.
Much faster, and that speed is the whole problem. Researchers from the Initiative for Interstellar Studies published new work this week, exploring how you could actually send a spacecraft to intercept it. The short answer is you need to do something genuinely extreme. They call it a solar Oberth maneuver.
Explain that to us.
So the Oberth effect is actually a principle used in basically every rocket launch. It says that if you fire your engines when you're moving fast, you get a bigger boost than if you fire them when you're going slowly. Normally, it's applied when a spacecraft is at the closest point of its orbit around the planet. What this mission proposes is doing it at the closest point of a solar orbit, a literal close flyby of the sun itself. We're talking 3.2 solar radii from the sun's surface. That is extremely close.
How close is that actually?
To put it in perspective, the Parker Solar Probe goes closer, but even that is an extraordinary engineering challenge. At that distance, the heat and radiation are intense. The spacecraft would need serious shielding.
But the gravitational kick from firing your engines that close to the sun is so powerful that you could theoretically reach speeds never achieved by human-made objects.
And then you'd still need how long to actually reach 3I-ATLS?
If launched in 2025, which the researchers identify as the optimal window based on the alignment of Earth, Jupiter, the Sun, and the comet, the spacecraft would reach 3I-ATLS by around 2085, at a distance of approximately 732 astronomical units from the Sun. For comparison, Voyager 1 has been traveling for nearly 50 years and is only at about 170 AU.
So this would be the most distant rendezvous in human history.
By a massive margin. And only a flyby would be possible, not orbit insertion, because both the spacecraft and the comet would be moving so fast. But even a flyby would be extraordinary, because 3I-ATLS didn't form in our solar system. It formed around a different star, possibly one that no longer exists. Its chemical fingerprints could tell us things about planetary formation elsewhere in the galaxy that we simply cannot learn any other way.
It's one of those stories where the scale of ambition just takes your breath away. Is there any serious movement toward actually doing this?
The researchers are clear this is a proposal, not a funded mission, but 2035 is only 9 years away. Decisions would need to start being made soon, and 3I Atlas won't be the last interstellar visitor. The more of these we find, the more valuable the case for chasing one becomes.
Staying in the realm of things we don't know much about, let's talk about China's Shenlong spacecraft, which launched on its 4th mission earlier this month.
Shenlong, which means divine dragon in Chinese, is one of those topics that generates a lot of fascination, precisely because so little is officially confirmed. This is China's reusable robotic spaceplane, broadly analogous to the U.S. Air Force's X-37B. It launched from the Jiuquan Satellite Launch Center on February 6th or 7th aboard a Long March 2F rocket.
And as usual, China hasn't said much.
Extremely little. The official line via state media Xinhua is that the mission will conduct, quote, technology verification and will provide technical support for the peaceful use of space. No launch time was given, no photographs, no mission duration, nothing.
But we can look at what the previous missions have done and draw some inferences.
We can. The first mission in September 2020 lasted 2 days. The second in 2022 lasted 276 days. The third, launched December 2023, lasted 268 days. So recent missions have been around 9 months in orbit. If this one follows the pattern, we might expect it to return around November or December.
And what have analysts pieced together about what it does up there?
This is where it gets interesting. Western space tracking organizations, including the U.S. Space Force and private space situational awareness companies, have observed that Shenlong conducts what are called rendezvous and proximity operations. It maneuvers close to other objects in orbit. It has deployed small objects, possible sub-satellites, during at least 2 previous missions. One of those objects was observed transmitting signals over North America, leading some analysts to describe it as a potential mobile signals intelligence platform.
And the anti-satellite angle?
Analysts are cautious. Some experts point out that Shenlong's small payload bay and limited power generation make it an unlikely direct space weapon. But the ability to approach other satellites at close range is inherently dual use. It could be inspection, it could be servicing, it could be something else. We genuinely don't know. What we do know is that the US X-37B's 8th mission is also currently in orbit. Launched last August to test quantum inertial sensors and high-bandwidth laser links. These are the only 2 countries flying reusable space planes right now, and they're both being quite secretive about it.
The new space race, conducted largely in silence.
Perfectly put.
Now, let's do a quick run-through of what else is happening on the launch front this week, because despite all the Artemis drama, the commercial sector does not stop.
It really doesn't. Today, February 24th, we actually have a launch scheduled from Wallops Flight Facility in Virginia. Rocket Lab's HASTE rocket, Hypersonic Accelerator Suborbital Test, Electron, is carrying a fascinating payload called DART-AE. It's a scramjet-powered hypersonic vehicle built by Brisbane-based company Hypersonics Launch Systems, and this will be its first ever flight. The mission is nicknamed That's Not a Knife, which we appreciate.
Australian hypersonics delivered with Australian humor.
Exactly. SpaceX also has a Falcon 9 Starlink launch out of Cape Canaveral today. Wednesday brings another Starlink from Vandenberg, but the standout launch of the week is Friday. Firefly Aerospace's Alpha rocket is returning to flight on the Stairway to 7 mission.
Tell us about that one.
So, Firefly's last Alpha launch was in April 2025, and it ended in failure. The rocket had an anomaly, and the mission was lost. This is their return to flight, and it's significant for another reason. This will be the last flight of Alpha in its current Block 1 configuration. They're upgrading to Block 2 for Flight 8, which introduces in-house avionics and thermal improvements. So Flight 7 is essentially a testbed for some of those new systems ahead of the full upgrade.
A lot riding on it.
Quite a lot. Then the week closes out on Sunday, March 1st, with 2 more SpaceX Starlink missions, one from Vandenberg and one from Cape Canaveral. By the end of this week, SpaceX will have surpassed 27 Falcon 9 launches for 2026 alone. The cadence is extraordinary.
And all of this happening while the SLS is making its 1 mile per hour journey back to the VAB. Quite the contrast.
The juxtaposition pretty much writes itself.
And we close today with some beautiful deep science. A new study published this week in the journal Nature Astronomy has solved a mystery about red giant stars that have had astronomers puzzled since the 1970s.
I love this one. So a bit of background. Red giants are what stars like our sun become when they exhaust their hydrogen fuel. They expand dramatically and undergo chemical changes. One of the most striking observations has been a consistent decline in the ratio of carbon-12 to carbon-13 in their outer layers. Scientists knew this had to be caused by material rising up from the nuclear furnace in the core, but they could not figure out how that material crossed the stable barrier layer separating the core from the outer envelope.
Until now.
A team led by Simon Bluin at the University of Victoria's Astronomy Research Center, working with colleagues at the University of Minnesota, used cutting-edge three-dimensional hydrodynamic simulations to model the actual fluid dynamics inside a red giant. And they found the answer. It's rotation.
Stellar rotation drives the mixing.
In a really dramatic way. Their simulations showed that in non-rotating stars, waves passing through the barrier layer transport very little material, which is what previous models predicted. But once you add rotation, it amplifies those waves enormously. Mixing rates exceed non-rotating stars by over 100 times, and they increase with faster rotation rates. That matches exactly what we observe on real red giant surfaces.
And these weren't small simulations. They used some serious computing power.
2 supercomputers, the Texas Advanced Computing Center at UT Austin and the brand new Trillium supercomputing cluster at the University of Toronto's SciNet facility. The principal investigator, Falk Herwig, described these as the most computationally intensive stellar convection simulations ever performed. They were only possible because of very recent advances in supercomputing.
And what does this mean for us, for our sun?
In about 5 billion years, our sun will enter its red giant phase. It'll expand and likely swallow Mercury, Venus, and probably Earth. Beyond the frost line, Jupiter, Saturn, and beyond, those worlds will move into the new habitable zone. This research gives us much better predictions of exactly how our sun's chemistry will evolve during that transition. What elements will appear on its surface, how fast changes will occur.
Which sounds like a very long-term concern, but understanding how our star will die is genuinely important science.
It is. And the techniques developed here have applications far beyond astronomy. The same simulation methods apply to ocean currents, atmospheric dynamics, even blood flow. Falk Herwig is already working with researchers in those fields to develop new large-scale simulation tools.
The universe teaching us about the ocean. I love it. And that is your Astronomy Daily for Tuesday, February 24th. Big day for Artemis, and not in any way anyone hoped. But as we've seen today, space science never stops, whether it's a rover finding its feet on Mars or scientists finally understanding why red giant stars change the way they do.
If you want to keep up with the Artemis rollback developments, we'll have updates in tomorrow's show once NASA has held that media briefing. In the meantime, you can find us at astronomydaily.io and at Astro Daily Pod across all your social platforms.
Subscribe if you haven't already. Leave us a review if you have a moment. It really does help. And we will see you tomorrow.
Clear skies, everyone.
Clear skies.